Okay, today we're going to talk about the quadratic formula and something called the discriminant. So that part might be new for you. We're going to solve quadratic equations using the quadratic formula. Okay, you will need your calculator for one of the questions, but we will start off without using it. If you would like to have it out, because it makes you feel safe and cozy, you can. Right, yes. So when you previously studied the quadratic formula, you likely used a calculator and you were finding decimal answers. Today, we are going to focus on finding those simplified answers, and that's actually something we're going to talk about very soon. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, and all of that is divided by 2a. So something that's going to be an extension this year is all of your solutions must be exact and simplified. Okay, all of your solutions must be exact and simplified. So when we have these terms, we need to make sure we understand what they mean. Okay, so if something is an exact solution, that means we're not going to have any decimals. Okay, if there's a decimal that can be written as a fraction, we're going to have that. If we have a square root, we're going to keep it as a square root, and it's going to be a simplified square root. So in terms of simplified, this really encompasses two things. We're going to reduce fractions. Okay, so when you're reducing fractions, we're looking for values that are the same in the numerator and the denominator. Okay, and we are going to simplify perfect squares under the radical. Is it okay if I just write the radical and put perfect squares? Would that be enough of a reminder that that's what we're going to look for? If not, you can feel free to write it out. Okay, and so when we start doing the quadratic formula, I want you guys to begin by identifying the A, B, and C. And this is something, once you plug those into the formula, okay, I want you to see how far you can go simplifying without your calculator. All right, let's see if we started this okay. So your A value is 2, your B value is -16, your C value is 27. So you guys may have noticed when I was reading off the quadratic formula, one thing I said is this is the opposite of B. I didn't say negative B, and that was intentional because when you are plugging this in, I think it's a lot easier for you to think of this as the opposite of -16, so you know it's positive, than to calculate the negative of a negative. So I always say the opposite of 16 plus or minus. When you do b squared, if you want to do that part in your head, you can. Something like that where you're doing 16 times 16. When you're practicing that on your homework, feel free to double check what 16 times 16 is. Okay, that will be 256. And then minus 4 times A times C. And this is how I usually set mine up. I will simplify this and I will simplify B squared right away. Okay, and then when I'm multiplying here, I have negative 4 times 2 times 27. So I'll write out 27 times 8 if I need to. 16 plus 5 is going to be 21. Okay, and then if you want to avoid like rewriting this over and over again, I'm fine if just on the top you write out 256 minus 216 so that if when you go to the next step, you can just write the simplified version. That's fine. Okay, so what did we get under that radical? What was 256 minus 216? Yeah, 40. Okay, so remember, we are simplifying radicals, which means we're looking for perfect squares underneath the radical. So when you're splitting this up, you either find the biggest perfect square, which is 4. So this would be 4 times root 10. Or if you want to do your factor tree, you can do that. So 16 plus or minus, what's the square root of 4? Everybody know? What's the square root of 4? 2. Okay, and then root 10. Now, when you have this divided by 4, you are going to have to divide both of these by 4. So I like to split it up so I remember to simplify each part. Okay, so 16 divided by 4, that's a whole number. So we got that. When you have 2 over 4, you can reduce because these are on the outside. So 2/4 is 1/2. 1 times root 10 is root 10 over 2. Okay, and then this is the part where you're going to have to ask yourself, can I take root 10 and divide by 2? Okay, you cannot combine something that is inside a radical and outside of a radical. So you're going to have to leave it as root 10 over 2. It can't be root 5. Okay, the only time you could simplify is if you had root 10 over root 5. If you had root 10, you had root 10 divided by root 2, that would be the square root of 5, not this. So if it's in a radical, you can't combine it with something outside a radical. It's only outside to outside. Inside radicals can be combined with other radicals. Okay, so this is going to be your final answer here. All right, so let's try g of x. 4x squared plus 3x plus 2. I want you to see if you can do the plug-in. Simplify as much as possible. Okay, so you have your A, you have your B, you have your C. Yep, so a lot of the things that we've done before are going to come back into here. So the opposite of B would be negative 3 plus or minus. B squared is 9 minus 4AC. Okay, all divided by 2A. Okay, so 4 times 4 is 16. 16 times 2 is 32. So here I know I'm doing 9 minus 32. Okay, and sometimes it's a little easier to think of it as 32 minus 9, or 32 minus 10, which is 22, and then you add one back. Do whatever you need to there, divided by 8. And then anytime you have a negative under the radical, did you guys remember the I? I know some of you did. I root 23. And then again, you can keep this as your two terms because we do like to write values with I in the form A plus BI. Okay, and then you can't simplify this fraction. There's nothing to simplify under this radical. There's no perfect squares in 23. It's prime. So that's how you know you are done. All right, and then let's try C. So C, the setup is going to be a little bit different. Okay, for A and B, we had f of x equals, we had g of x equals, but it could also be equal to 0. Okay, it says find the zeros using the quadratic formula. So anytime it tells you how to solve, make sure that you are using that. And when you're finding the zeros, you are just finding your solutions. Okay, you are finding those values of x. Okay, so in this one, your A value is what? -1. Your C value is -8. Oh, sorry. Your B value is -8. Your C value is 10. Okay, so I'm going to give you a couple moments to start that. If you get stuck, it's okay. All right, let's see how we're doing so far. So the opposite of -8 is +8. -8 squared is 64 minus 4AC. I want to see if we did this part correct. If you have a -4 times a -1 times 10, you get a +40. So what you should be doing here is adding 64 to 40. How did that go? So how'd that go? Good. Okay. So if you have a negative times a negative, we do have to change it to a plus. And then did we know what to do when we got 104 underneath? Because we got to check for perfect squares. So what should we do? We're not using our calculator. That makes my factor 3, right? So with 104, let's see what we got. Okay, I do think with the larger numbers, it's easier for you to start with a prime number like 2 or 3 if it goes in there. Okay, if it's even, 2 is going to go in there. So half of 104 is 52. So 2 goes into 52. 20. Okay, and then just do half of 50, half of 2. 25 plus 1, 26. Half of 26, 13. Now, the reason why we're looking for a pair is because if you have 2 times 2, really, all of those are being multiplied together, okay? The square root of 2 times 2 is 2. Okay, so if you have that, a 2 comes out. Let's look at what's left inside. These don't have, yeah, the square root of 26. So 2 and 13, 2 times 13. So this is 8 plus or minus 2 root 26. And then I'm dividing both of these by negative 2. So this one is a little bit different. So you have negative 4 plus or minus. These do simplify, right? The 2 and the negative 2. And it is a negative root 26, but let's talk about what this means. This is negative 4 plus negative 26. Isn't plus a negative the same thing as minus? Yeah. And if you minus a negative, it would be the same thing as adding. So you can keep it like this in this case, or if you wrote it like this, I would not mark that wrong. I just want you to know plus a minus is a minus, and minus a negative is a plus. Okay, so technically you can write it like this, okay, or you can have this. I don't know if they do that. Okay, so that is going to be your final value, okay? Now, we're going to write a little note. I'm going to put it here. If you don't have any room here and you want to put it at the top, that's fine. It's just there was a situation that people kept asking me about when you're solving by a quadratic. So I wanted to make sure I went through some of the harder examples with you. But let's say that you get something like this, okay, that you have 8 plus or minus the square root of 25 divided by 2. Okay, so we didn't do one where you had a perfect square under the radical. If that happens, you are going to write out the 2 answers. So you know the square root of 25 is 5. So this is 8 plus 5 divided by 2, and 8 minus 5 divided by 2. So there are going to be a few cases on your homework that you can simplify just by simply adding. So 8 plus 5 is 13 divided by 2, just leave it as a fraction. Okay, and then you would just say x equals that, or this would be 3 over 2. Okay, so 13 over 2 or 3 over 2. Okay, this is if you have a perfect square. So I just wanted to make sure we went over that so that when you get to it on your homework, you can be successful at it. All right, and then example 2 is where we're going to use our calculator. So we are going to practice some calculations with the quadratic formula. We know multiple ways to solve this problem, but this section is all about the quadratic formula, so we are going to be applying it here. It says a diver jumps from a diving platform that's 10 feet high. Her arc can be modeled by, we're going to use the equation y equals negative 4.9 x squared plus 2.5x plus 10, where y is her height in meters and x is the time in seconds. I always like to highlight the question. It's asking us how long it will take for the diver to enter the water. Anytime they're asking you how long something takes, that means you have to find the time. Okay, if you're trying to find the time, let's just identify whether that's an input or an output. So they tell us x is the time in seconds. So is x our input or our output here into our equation? It's your input value. So y is your output, x is your input. That's what you're gonna find. Okay, and if you would like to draw a little picture, you can. My pictures are very basic. This is the diving board. This is the pool. This is the happy diver. Yeah. So you're finding, like, when you are looking for your value, it's going to be the x. And so x is whatever you like can plug in. Yes. All right, and then let's model the quadratic. That's what we have here, a quadratic equation. Okay, so they jump, they hit the water, they follow this parabolic form. Okay, so you're trying to find the time in seconds for them to hit the water. Okay, and you are going to try to find that value. Okay, this value is also going to be present. We're going to find that value as well. Okay, but we're going to see why we're going to have to reject that answer. So with your decimals, you have your x squared coefficient. Don't keep the x with it. Okay, so your a value is in front of x squared, b value is in front of x, c value is the constant. Okay, and then I want you to plug those in, and then we're going to use our calculator to calculate. Yep, so I want you to try to plug it into the equation. And see if you can do the calculation on your calculator. And sometimes we think we know how to plug something in, and then we do the calculation, and it's a little bit off. All right, let's see how this went. So we have the opposite of b plus or minus. Now before, when I was doing the b squared, I would simplify it because that's something I could do quickly. With the decimal, I'm not even worrying about that. I just want to make sure I have everything plugged in correctly. And then I'm going to do my calculations with my calculator. Okay, so what I like to do is I like to find the solution for what is underneath the radical. You can plug this all in at once. You just have to make sure that you plug it in correctly, which some of you will see very soon whether we did that right. Okay, but if you have something that turns out nicely, so I have 2.5 squared minus 4 times negative 4.9 times 10. Okay, I get an ending decimal, so something that doesn't go on forever. And if that's the case, I just think it's easier to work with that. And then I know this is going to be a nice number as well. Okay, and then I'm going to put that in my calculator. So there's two ways that I can do it. And remember, you're going to have two answers. So first we're going to add them together, then we're going to subtract them. And this doesn't say what to round to. On any type of assessment, I will tell you what to round to. Okay, so to make sure that you're practicing your rounding rules. So one way you can do this is you can take the square root first. Actually, you can do this whole thing first. 2.5 plus the square root of 202.25. Okay, you can get the numerator and then you can divide by the denominator. So we get negative 1.196 dot dot dot. I'm going to practice your rounding with you in a moment. Okay, if you didn't get that and you put it all in at once, it's probably just because of the way that you put it in. So if you put this in at one time, when you have a fraction, there are parentheses around the upper portion if there's a plus or minus. So you can put your parentheses. Some of your calculators, you can actually just highlight this and you can change this to minus, which is a little less typing if you want. Oh, thank you. Okay, so with some of your calculators, if you highlight this, okay, you can enter it and put it back down there. And then we're going to divide. Okay, and then if you needed to like do this again for the plus to double check it all at one time, you could just change that and you have your two solutions. So because we're working with time, we know our time value isn't going to be negative, so we can reject that answer based on it's not going to fit our story problem. Okay, and then we're going to round this to the nearest hundredth. So we get 1.71 seconds. If it's a story problem, include your unit. Okay, include the unit of time. Okay, and that 6 is going to round that 0 up. Okay, so make sure you're practicing putting that in your calculator to make sure you know how to use the proper symbols. Okay, some calculators are picky about the negative versus the minus sign, so we want to make sure we're comfortable with that. Okay, the other thing we're going to talk about today is called the discriminant. So the discriminant is the value underneath the square root. So b squared minus 4ac. Okay, that is the part under the radical in your quadratic equation. Now what this does is it can tell you the number and the type of solutions that a quadratic equation has based on whether it's positive, 0, or negative. Okay, so we're going to talk about all the cases here. So if the discriminant is positive and a perfect square, there's something we can tell from it. If it's positive and not a perfect square, it's going to be something different. Okay, and positive is the only one that's going to have two cases. Okay, so if it's positive and it's a perfect square, that's going to give you two real rational roots. If it's not a perfect square, they're going to be two real irrational roots. Is there anything you remember from previous math classes about what a rational number is or what an irrational number is? Yes, one of them is going to have something special about the decimal. Can we expand on that further, anybody? So if it's rational, the decimal goes on forever. If it's irrational, then it's going to well, if it goes on forever and it repeats is what would have to happen. It's irrational if it goes on forever and it does not repeat. And anything that's rational can be written as a fraction. Okay, so if it's something that's rational, it can be written as an integer, which integers are just positive or negative whole numbers, or a fraction of integers. Right, like 1/3. 1 and 3 are both integers. 1 and 3 are both integers. So if you have something that's rational, like 1/3 is 0.3 repeating, right? So it's a repeating decimal, that's okay, because you can write it as a fraction, 1/3. Okay, the same thing happens with 2/3, right? 0.6 repeating, okay, so that is also rational. It is irrational if it's a decimal that goes on forever and does not repeat. So when you're looking at the graph for these, if you have 2 real roots or 2 irrational roots, that means that you have 2 x-intercepts on the graph. Okay, the next case is if the discriminant is equal to 0. So b squared minus 4ac is equal to 0. Okay, if that happens, then you only have 1 real rational root. Okay, so if it's positive, you have 2. If it's 0, you're going to have 1. Okay, rational if it's a perfect square. This one follows the same thing because 0 is a perfect square. That's why it's rational. All right, let's think about what our graph is going to look like. We have graphed ones like this before. If you have 1 real rational root, it's when you have the vertex on the x-axis. Okay, if the vertex is on the x-axis, that it is when the discriminant is going to be 0. Okay, and your last case is when it's negative. Remember, this is the part underneath the radical. You have a negative radical, what type of solutions does that make? Yep, they have I. So we call those imaginary, or do you remember the other word we use for them? No?
Irrational.
Complex. Okay, so we're going to say they're 2 complex roots. Okay, so imaginary, complex roots are the same. All right, so if you have 2 imaginary roots, the complex roots, what that means is you don't have any real x-intercepts, so it would look like this on the graph. Okay, there would be no x-intercepts visible. Okay, the only x-intercepts that exist are real. So if you have complex values, you will not see them on the graph. Okay, so the directions for this say to find the type and the number of solutions for each equation. The directions don't specify to find the discriminant, but that is what we are doing. So you are going to find the discriminant for each. That's also how it will be on your next assessment. Okay, so we're just going to abbreviate and we're going to make just a line above the line for each one to find what the discriminant is. I guess for these I started underlining this. Now I have to make them all. Okay, so when you find the discriminant, all you have to do is find b squared minus 4ac. Okay, we'll do the first one together, and then I'm going to have you do the other two. Okay, and you don't have to write out what these are all the time. You're going to see them from the equation. Okay, so your a value is 1, your b value is negative 12. So negative 12 squared minus 4ac. Okay, what is negative 12 squared? That's 12 times 12, 144. Okay. When you're multiplying 4 times 36, just multiply 30 times 4, because 30 times 4 is what? 120. 6 times 4, 24. So then you can just add those together. That's easier when you're doing mental math. So your discriminant is 0. So based on that, if you can use the chart above to say the number of types and zeros, go ahead. Okay, if you want to take a look at it and go on and find the discriminant for the next one, you can do that. Okay, so I want you to find your discriminant for the next two. Just pay special attention to part C. Don't let it get you. Oh. All right, so A is 1, B, C. Okay, so you have b squared minus 4ac again. So 144 minus, what's 4 times 4? 16. So then you just put the 0 on that, okay? And then when you're subtracting, if it's easier, just do 160 minus 144. I kind of add up, like 6 gets me to 150, 10 gets me to 160. So this is going to be negative 16. You can think of it like that. Okay, and then I told you to watch out on part C because these you have equal to 0. If you don't have it equal to 0, what do we have to do? Move it over. Okay, so we're going to have to add 30 to both sides so it's equal to 0. Then we can do b squared minus 4ac. Okay, for every single one, we're doing b squared minus 4ac. Okay, so we have 144. 4 times 3 is 12, so we're going to put the 0 on there. Okay, so that's our discriminant. All right, and then let's go back and fill these in, and then we'll do part B. So for the first one, it's 0. If it's 0, your number and type is one real rational root. Yeah, a lot. So one real rational root. Okay, now if it's negative, negative 2 complex roots. Okay, and then if it's positive, you just have to ask yourself if it's a perfect square or not. Is 24 a perfect square? No, right? 25 is a perfect square because it's 5 times 5, but nothing multiplied by itself is 24. So if it's not a perfect square, 2 real irrational roots. Okay, so you should be able to do this one all the way through. And sometimes I just do that for the A, B, and C. Okay, so you have 7 squared minus 4AC. Now, we know 7 squared, 49. Do you see here you have a negative times a positive? So that means this is going to be plus, yeah, positive. And then what's 4 times 3? 12. So that's going to be 12 times 20. So what's 12 times 2? 24. So it's just 240. Okay, 240 and 49 is 289. So it's positive. We just have to think about, is that a perfect square or not? Okay, and then when the numbers are big like this, if you want to double check that with your calculator, you can. Okay, if you take the square of 289, is it a whole number?
It is.
What is it? 17. Yep, so it's a perfect square. Okay, so then it's 2 real rational roots.